Good morning, friends. Today we are going to discuss on shear force and bending moment diagrams and the relation between shear force and bending moment diagrams. Up till now, the previous session we were discussed about the shear force and bending moment diagram of simply supported beam, continuous beam, not the continuous beam, cantilever beam and overhanging beam. In the same series, today we are going to discuss the last two problems and we will see how the shear force and bending moment diagram can be plotted with the variety kinds of loading, point load, uniformly varying load, uniformly distribution load and couple. So, let us go ahead with the today's objective is to learn shear force and bending moment diagram. So after this session you will able to do the following. First, to describe the shear force and bending moment, to plot shear force and bending moment for overhanging beam, and to study the relation between shear force and bending moment. Let us revise what is shear force and what is bending moment. When a beam is loaded by forces or couples, stresses and strains are created throughout the interior of the beam. These internal quantities are referred as shear force and bending moment, and our intention is to find out these internal quantities. Let us refer this particular figure of a beam. This beam is subjected to the various kinds of loading. These loadings are known as external loadings. Now, to find out the internal loadings, let us take a section XX over here. Because of this section, my beam will be divided into two parts, left part and right part. So, you just see the left part. This is the free body diagram of the left part of a beam. See this one. These quantities at a cross section XX are referred as shear force and bending moment. Then how the shear force is defined? Shear force is algebraic sum of all the vertical forces acting to the left or right of a cut section along the span of the beam, while bending moment is the algebraic sum of all the moment of the forces to the left or right of the section taken about a specific section. Now let us understood the sign convention which is used for shear force and bending moment. Now, to understood this sign convention, refer a figure of beam. Let us divide the beam by taking section XX. While we take a section XX, my beam will be divided into two parts, left part and the right part. For a left part, if a force having an upward direction nature, then it is to be treated as positive shear force. This is my or our sign conventions that we have been used throughout the series of 1, 2 and 3. Opposite to that, if a beam having a section, the force which is acting downward direction treated as a negative shear force. For bending moment, for a section XX, that we know this is a section, so this is my left part and this is my right part. So for this left part, if my moment having a clockwise nature, or for a right part, if a moment is having an anti-clockwise nature, it is referred as sagging bending moment, and which is treated as positive bending moment in our series. Opposite to that, for a section, for a left part, anti-clockwise moment, or for a right part, clockwise moment, this nature of bending moment is known as the hogging bending moment, which is treated as negative bending moment in this particular series. Now, what is the procedure to determine the shear force and bending moment? We are using static equilibrium approach for the determination of SF and BM, and then we plot the SF and BM. The steps. The first step is the find out the support reaction. Now, support reactions, definitely we are studying right now statically determinate beam. Means 3 beams we are going to study right now. The name of the beams are simply supported beam, cantilever beam and overhanging beam. In all the 3 cases, the numbers of unknowns are 3, means the 3 reactions are unknown. When the 3 reactions are unknown, we can easily use the 3 equilibrium conditions, that is sigma h is equal to 0, sigma v is equal to 0 and sigma m at any particular point is equal to 0. Using these 3 equilibrium conditions, we can easily determine the reactions. Then we have to cut the beam at a certain cross section and we have to draw the free body diagram of one piece of the beam, either left of a section or right of a section, and we have to determine the shear force at that particular section by using the basic concepts. Means we have to set up the equations. Then we have to solve for shear force and bending moment at that particular cross section, and then we can find out easily the shear force and bending moment at that particular section. After finding the shear force and bending moment at various sections, we can draw the shear force and bending moment diagrams easily. So, up till now previous case, in case of series 1 and series 2, also majority in series 3, we had solved numbers of numerical problems. Corresponds to simply supported beam, cantilever beam and overhanging beam. We have understood the basic concepts. Using these concepts, let us we go ahead today's 1 or 2 problems of overhanging beam right now. So this is the problem. These problems we have solved for shear force diagram in the previous lecture. Please recall. So the first questions will arise in our mind: which kind of beam is given to us? Here the support which is of hinge, here the support which is of roller, definitely. And this part which is of projection beyond the support, definitely it is known as overhanging beam, subjected to UVL, uniformly varying load, moment, concentrated moment, point load and UDL. In the last lecture, we have also found out the support reaction using the 3 equilibrium conditions, and we got that answers, that is RB is equal to 32.5 kilonewton while RAV is equal to 42.5 kilonewton. So we found out this answer also in the previous case using the 3 equilibrium conditions: sigma h is equal to 0, sigma v is equal to 0 and sigma ma is equal to 0, that is a summation of all the moment of forces at point A, which is equated with the 0. So using these 3 equilibrium conditions, we can easily find out the reactions. So also in the previous lecture, we have also drawn this bending moment diagram, shear force diagram we have already drawn. Let us we understood this diagram carefully. Let us we establish the relations corresponds to loading with the shear force, and then we will proceed further with the bending moment. Refer the figure. As in the span, the UVL is acting in the span of 2 meter, the shear force diagram changes by parabola. Next observation: at a point load or at a support, there is a sudden change in the shear force diagram. After that, the UVL is acting in the region of 2.5 meter. The relationship for the shear force which has been shown by parabolic shape of the diagram. I will repeat, we have already studied this diagram in the previous lecture, so I am not going to detail explain about the how this magnitude or how this load or how the shear force exact value will become, because have already been explained. Now next, here the concentrated moment is acting at this particular point. There is no effect at all in the shear force diagram directly under the concentrated moment. Yes, the effect of this concentrated moment is for the calculation of support reaction, but there is no direct contribution for the plotting of shear force diagram. Between this point and this point, there is not a single load. Hence, the variation of shear force diagram which is shown by horizontal straight line. Under the action of point load, shear force changes abruptly. Sudden change will be there. After that this is an application of UDL. The shear force relation which has been given by inclined straight line. And for support reaction is nothing but a point load. There is a sudden change in the shear force diagram. So I wish you will understood these basic concepts, and let us proceed further with the bending moment diagram using this tabletop. So now let us plot the diagram over here. The given beam, which is of overhanging beam, the load which has been given to us is of UVL, this ordinate is of 20 kilonewton per meter. Here there is a clockwise concentrated moment is acting 30 kilonewton into meter. The point load which is acting of 20 kilonewton. The distance are of 2 meter, 2.5 meter, 1.5 and 1. Let us give the name A and B at the support, then C, this point is D and this point is E. Now we know the support reactions, and the reactions are 42.5, that is of RAV, and RV is of 32.5. So we know these reactions, and our intention is to plot bending moment diagram. So this first line that we had been plotted right now, that is known as baseline. Please see in this tabletop. Now refer the figure. At C point, the load which is acting 0. So moment at that particular point itself is 0. That is known to us very well. Now next point is about A point, that is bending moment at A. So what we have to take? We have to take a section either left side or the right side. So for the easier point of view, let us take a section on the left side. The load which is acting only of UVL, because of this UVL, the moment which is acting at A is equal to load multiplied by perpendicular distance. What is load? Half into 20 into 2. This is load. multiply by perpendicular distance. Distance is this one, CG is over here. Distance is this one, that is of 1/3 of 2. Now question is about the sign convention. This load which creates an anti-clockwise moment, but repeat, section left anti-clockwise, which is treated as negative, and this gives us minus sine 13.33 kilonewton into meter. This is the moment which is acting at A. So now this comes to be 13.33. As we have discussed in the previous lectures that beam with UVL, the variation in case of bending moment diagram which is given by cubic parabola, so we have this kind of relationship. Even though if you want to check whether this relation is right or wrong, you have to take a center point, that is at 1 meter. At 1 meter you have to find out the ordinate of load, then you have to find out the total load, multiply by perpendicular distance, that is the moment at 1 meter. You have to find out the ordinate and join this 1, 2 and 3 ordinate. You can easily fetch up, you can easily obtain this shape of the diagram, that is the cubic parabola. Next is the point D, that is our interest or concern. But at the point D, a concentrated moment is acting. As such, the concentrated moment is acting, then there is a sudden change. Over here we can visualize in case of bending moment diagram. Hence, I will take just left of D, our section. So, what I will do, I take bending moment at D, just left